So, in the this is lecture number 8 of irrigation and drainage lecture series. So, in this lecture we are going to learn the crop water requirement. So, the previous lecture, this lecture number 7, we learned evapotranspiration. So, now in this lecture, so the crop water requirement. So, and then here, what is crop water requirement? So, in the previous lecture we focused only evapotranspiration. So, if the evapotranspiration is extended for the whole crop period, okay. So, that we call like crop water requirement, the whole crop water, I mean from the day, for example, in case of rice you are talking, the day you transplant and give first irrigation, right, to the last irrigation. So, that is the crop water requirement. So, the amount of water exactly needed to compensate the evapotranspiration loss from the crop field is termed as crop water requirement. Okay. So, the amount of water needed to compensate the evapotranspiration is called the crop water requirement, and crop water requirement represents the ET under ideal crop growth condition. Okay. And crop water requirement varies with time and space. Okay. So, during which time the crop amount of water, for example, at middle of the crop growth or the initial period or end of the period. So, that really the crop water varies with time as well as the space, right. So, in the like in the tail end, head end, okay. And as the ET demand varies with local climate and crop conditions. So, ET basically depends on the climatic conditions and also the crop condition, which stage the crop is at. Okay. And then, so here what are the factors affecting crop water requirement? Mostly the factors which are affecting to evapotranspiration or affecting crop water requirement. So, so here some of the factors are like crop factors, for example, type of crop, cultivars or species, and growing stage, which growing stage, right, leaf area, okay. So, then root length and root density. So, all are going to influence the evapotranspiration and as well as the crop water requirement. So, and weather factors such as temperature. So, increasing temperature definitely increases evapotranspiration and the crop water requirement, and radiation, humidity and wind speed. Okay. So, these factors definitely influence the crop water requirement. Some are positive and some are negative. For example, here humidity, if you have a lot of humid, crop is under humid condition. So, the evapotranspiration will be less and crop water requirement may be less. Okay. So, here this graph clearly shows a typical pattern of ET demand during the growth period of the cereal crop. So, initially ET demand will be less, then and after that ET demand is increasing, and then it is going to decline at the end of the season. Okay. So, because at the end of this is similar to human beings. So, similarly you in the beginning you need less food, and the younger stage you have to get more food or more food and more water, right. Then after that, in the old days, right, in the olden days you do not require to eat a lot of or you do not require to intake a lot of food. So, this is going to fall down. Okay. And then the next is how to calculate this crop water requirement. So, for the crop water requirement as similar to ET. So, ET is daily ET you get. So, if you can combine that, so as sum of all daily ETs, and you get the crop water requirement of the whole season. So, the crop water requirement for a given crop, the whole growing season. So, this is ETI is, so I indicates for crop water requirement for the growing period, okay, for a growing period, and ETI crop evapotranspiration for the growing period, right. T is the time interval. Okay. So, where t is equal to 0 to m, the time interval. So, E t 0 t evapotranspiration, okay, at I 0 and t into K C t. So, K C t at a particular time. Okay. So, you get evapotranspiration for a particular time, this is the time. Okay. So, you get E t here, E t 1, E t 2, E t 3, then if you can sum up all those E t's, right, and you get E t for a particular crop. So, this is I is the crop, particular crop. Okay. So, if you have number of crops in the field, for one crop you get E t this much, I mean crop water requirement this much, and if you can combine whole crops you get total crop water requirement for the whole field. Okay. So, then so the next is, so then what is the difference between crop water requirement and irrigation water requirement? So, definitely crop water requirement is subset of irrigation water requirement. So, the crop water requirement has the function of weather and crop. Okay. So, whereas irrigation water requirement it depends on weather, crop and soil, rainfall, irrigation method, depth of water table. So, this has a lot of parameters, where crop water requirement it is a weather condition because it gets E t and the type of the crop. So, it get the growing period, total growing period. So, whereas irrigation water requirement, so the weather, crop, soil, so these all decides the soil moisture, right, soil moisture, and then the rainfall, irrigation method. So, depth of water tables is also influence the irrigation water requirement. So, that is why crop water requirement always less than the irrigation water requirement. Okay. So, here crop this table shows the crop water requirement for some of the major crops. So, if you see this, the rice is 110 to 160 centimeter of water is a crop water requirement, and also the sugar cane is also larger crop water requirement 150 to 200 centimeter. So, the least could be like lentils, like 15 to 25 centimeter. So, it varies from crop to crop, right, and also how long the crop is really there in the field. So, here the sugar cane it is the whole year, right, mostly the rice could be one season, right, this is seasonal. So, this way the irrigation water requirement always more than the crop water requirement. Then irrigation water requirement. So, the net irrigation here water requirement is the quantity of water required for successful crop growth. So, not just like a crop water requirement. So, irrigation water requirement, that means from the day the field is prepared to the day after harvesting, also if you are using some water. So, this all water is irrigation water requirement. So, that is why the water amount is more than the crop water requirement. So, it has a weather, crop and soil factors influence in determining the irrigation water requirement, just like evapotranspiration, just like crop water requirement. The irrigation water requirement also has the factors like weather factors, crop factors, soil factors, what we discussed the factors for other two parameters. So, here for example, soil factors. So, soil type, so storage and release properties of water. So, soil type in the sense, if you have sandy soil, if you have a fine textured soil, sandy loam soils. So, the storage and releasing properties definitely influence the irrigation water requirement. So, the organic matter content, right, the control its storage and release properties. Okay. This is the organic matter content. If you have a lot of organic matter content, it holds the water, and you may need to give less water for as irrigation, because already water present in the soil. So, soil texture, the seepage and percolation rate. So, sandy soil has greater percolation or CPS rate than silty soils than clay soils. So, the sandy soils requires more irrigation water compared to the silty soils. And the other factors are effective rainfall. So, the part of rainfall which is effectively used for filling the soil reservoir, that is called effective rainfall, and water required for leaching of salts. So, this is also suppose your field has a lot of salts, then you have to use more water to leach this salts. And the water required for land preparation and land soaking. So, this is also the an amount of additional water required under field preparation. So, not only for giving water for the crop, but also for preparing the field for favorable soil condition to the plant, and that water really required, and that is also included in the irrigation water requirement. So, then what are the components of total irrigation water requirement? What are the components? So, the total irrigation water requirement has the following components. Okay. So, here the first one is the water for land preparation and water for land soaking and crop water demand, that includes ET and CPS and percolation. Okay. And water for leaching requirement, if you have salts, saline soils, then the amount of water is required to leach the salts, and water for special use such as crop cooling, freezing protection. So, you are cultivating crop under cold conditions, so sometimes soil might be frozen. So, you need to apply water in order to defreeze the soil, right. So, that plants can extract that water. So, irrigation water just said. So, if you are talking, this is demand, this maybe this is a crop water requirement, but in addition to that, so the other water uses like water land preparation, land soaking, leaching and special use crop cooling. So, this all together adds up to total irrigation water requirement. And then let us focus on estimating individual components for total irrigation water requirement. So, the first one here is water for land soaking. So, the water for land soaking here which is equal to Ws. So, that is water required to saturate the soil, okay, and this will give the crop water demand, and so the P is the depercolation and Re is the effective rainfall. So, you use this, for land soaking, suppose initially the land, you have a piece of land, and in order to soak with water and before growing any crop. So, this land needs to be wetted. Okay. So, then you need to apply some water, right. So, and the device, it all depends on definitely this is, suppose you are applying this much water to a device. So, definitely the amount the application efficiency come into the picture, because there may be some losses from delivery point to the point of field application. Okay. So, and then during the process, so water required for saturation, first water is needed for saturation. So, once it is water is available for saturation, so then definitely there is a evaporation, right, from the open surface, and then there is a depercolation, that is a P, and then if you have during that time, if you have effective rainfall, so that is called Re. So, that is added so that will be the extra amount you are adding to that. So, this much you can subtract and give that is the point. So, the water for land soaking, which is equal to the water used for saturation, and this is the evapotranspiration during that time, and P for depercolation, that is another loss. So, these are all the losses, right, these are the losses, and then this is additional amount you are giving and the efficiency term if you put, this is the total water for land soaking. And the next point is water required for land preparation. So, water required for land preparation has water depth for submergence. So, this is the submergence and again this is the demand, crop demand, and then P. Okay, so, this is the depercolation and effective rainfall and then application efficiency. So, this is for the land preparation. Similarly, water required for leaching we are talking about the salts. So, here leaching requirement is equal to, so ECW, which is the salinity of the applied irrigation water. So, water has some salts, okay, salinity of that. So, that is ECW. EC is electrical conductivity. So, salinity is represented with the EC, electrical conductivity, that is W, and 5 ECT. So, this is kind of a threshold salinity. So, average soil salinity tolerated by the crop. So, each crop has a tolerance level, right. So, based on that we decide what is ECT. So, that is 5 times ECT minus ECW. So, this will give the leachate requirement. Okay. So, the water required for leaching the salts is estimated using this equation. So, then next is the total depth of water for a season to meet irrigation and leaching requirements. So, the total irrigation and leaching requirement. So, this is the total depth of water in a season. This is the demand, crop demand. 1 minus LR will give the both crop as well as the leaching requirement for the salts, removal of salts. Okay. So, this is the seasonal. Suppose you have 0 leaching requirement, right. So, available or applied water which is equal to ET, okay, because you are not using any water for leaching requirement. So, then the other component of this total irrigation water requirement is irrigation water requirement for normal growth period. So, this is a crop demand, right, and P and RE plus GWC, that is a groundwater contribution during the period, and RE is again. So, these two are positive because this is from precipitation, this is from groundwater, right. So, this water you are adding. So, P is the loss, these are the losses, right, these are the losses and these are the inputs, you can say. So, this is the demand of crop, and then P is the depercolation. So, if you are talking daily and this is summing up, you get irrigation water requirement during normal growth period. Okay. So, here the normal growth period from sowing to transplanting to the last watering. Okay. So, from sowing to transplanting to the last watering. Okay. So, I mean you can say the water period, the first irrigation is the last irrigation period. And the next is the finally once you get all the components, the total irrigation water requirement. So, this is the total or net irrigation water requirement is water requirement for land soaking, water requirement for land preparation, and water requirement for ET demand, and water requirement for leaching. So, we have equations already defined earlier. If you can combine all these waters and you get net irrigation water requirement, and if you have efficiency terms, then you get the grass water requirement. Okay. So, here the net water requirement, net irrigation water requirement based on moisture deficit. So, moisture deficits as earlier I explained how to give irrigation or that. So, this is the field capacity and soil moisture. So, that difference, right. So, decides, and also the DI is the root zone depth. So, this will give the deficit. Okay. And if you have leaching requirements, so this is the leaching requirement. So, then if you can use this equation, you get net irrigation water requirement based on the moisture deficit criteria. Okay. So, then once you have net irrigation water requirement, so the grass irrigation water requirement is equal to net irrigation water requirement divided by application efficiency and then conveyance efficiency. We are going to talk about this efficiency in the coming lectures, but this is from field conveyance efficiency and field application efficiency. So, you have conveyance efficiencies generally from canal, right. So, you have this is a canal. From canal the water is delivered to the fields, right. This is the field, right. So, suppose you have Q1 here delivered and Q2 you received, right, and Q3 you applied. So, here Q1 minus Q2 divided by Q1 will give the conveyance efficiency, because you are not getting Q1 at the tail end here, whereas here Q2 minus Q3 divided by Q2 you will get the EA, application efficiency. Okay, so, we are going to talk about this more later. So, then so steps required for total irrigation water requirement. So, the first step is identify the climate zone and agroclimatic zone of the project area. First thing is it kind of reconnaissance. So, you just go there and see what is the climate zone and agroecological zone of the project area. Then the next thing is to select the appropriate crop and cropping pattern for the area, so which are suitable for the agroclimatic zone. And then third, collect the long term climatic data and soil information. So, next is you have to collect the long term information on soil information as well as crop information. And then fourth is calculate the reference evapotranspiration from the crop period. So, you can based on the data available with you, like weather data and everything. So, soil data, weather data, you can estimate the crop evapotranspiration for the whole crop period, and collect the crop coefficient values from the literature from the saline similar crop and varieties. So, once you estimate the evapotranspiration or reference evapotranspiration for that particular area, right. So, then what else you required is your crop coefficient. So, you can multiply with the evapotranspiration, reference evapotranspiration, then you get crop evapotranspiration. Then you calculate crop evapotranspiration ETC. This will give the crop water demand, and then calculate others special water requirement. So, that we just seen irrigation water requirement like land preparation, soaking, leaching requirement, salt balance, everything. And then determine the water requirement, right, net water requirement. So, using the formulas, estimate the overall water conveyance efficiency and application efficiencies, and then finally, you get the irrigation water requirement, irrigation grass water requirement by dividing the NIR by EC by EA. So, this way we have to estimate total irrigation water requirement. So, we started with evapotranspiration, right, and then crop water requirement, and then irrigation water requirement, and then total irrigation water requirement. So, this way even before that you can put this is ET0. Okay. So, ET0 and then ETC and then crop water requirement and irrigation water requirement and total irrigation water requirement. All right. So, here is the example. So, the following information is available for a land. So, first one is the depth of water required to saturate 20 centimeter soil is 6 centimeter, right. You have like 20 centimeter soil, let us say depth of 20 centimeter soil is 6 centimeter. Okay. So, daily reference evapotranspiration is 5 mm, this is ET 0, and time from water application to deplete field capacity 6 hours, okay, and deep percolation lasts during soil saturation 4 mm. Rainfall during the period is 0, no rainfall. So, determine the irrigation water requirement for land soaking. So, irrigation water requirement for land soaking. Okay. So, this you need to find out. We have an equation, okay. You can bring the equation here and substitute the data. Okay. Let us see the solution. The solution is like this. So, the irrigation water requirement for land soaking, so that is IWRLS has a formula WS C into ET 0, P deep percolation, RE effective rainfall, application efficiency, conveyance efficiency. So, what are given? WS is given 6 centimeter. So, convert that into 60 mm, okay, in mm, and P is given 4 mm, rainfall 0, ET 0 per day is 5 mm. So, but we have like 6 hours, right. So, ET 0 for 6 hours. So, day let us count like 12 hour a day, okay. So, that is the day time. So, the half of this you get ET 0 for 6 hours, and EA 95%, EC 80%. So, you substitute, all the values are here. So, substitute here, sorry, 60 mm, all in, if they all are in mm. So, then sorry, okay. So, all in mm, C you can consider 0.95, okay. ET 0 here, ET 0 is given, right, and P is given 4, RE is given, where is RE? Oh, effective rainfall. So, this is RE, that is 0, and once you substitute everything, IWRLS is equal to 87.3 mm. Okay. So, that is irrigation water requirement for land soaking. So, next example, that is 8.2. So, in this example, this is a winter crop, is given like this is a winter crop grown in spring. The following information is gathered. So, for a particular growth phase. So, reference evapotranspiration for growth phase is 30 mm. So, ET 0 is 30 mm. The crop coefficient Kc is 1.0, and deep percolation application. So, that is P, which is 4 mm, and groundwater condition contribution is 0. So, that is U, which is groundwater contribution, that is 0. So, find net irrigation requirement and gross irrigation requirement if the application efficiency and conveyance efficiency are different. So, once you get net irrigation requirement, right, divided by EA into EC. So, that will be the gross irrigation requirement, irrigation water requirement. Okay. So, let us see the solution. Yeah. So, the solution here, if you see the given values are ET 0 30 mm, Kc 1, P 4 mm, Re 5 mm, groundwater contribution 0, 85 EA, that is application efficiency, and conveyance efficiency 70%. So, net irrigation requirement has the if you recall the formula, right, WRNC equal to Kc into ET 0 crop demand, and P, which is deep percolation, this is the loss, these are all losses and these are all gains, right. So, putting the values you get 29 mm as net irrigation requirement, and 29 divided by the efficiency stems you get 45.5 mm. Okay. So, this way you can estimate the irrigation requirements, okay, knowing the other losses and inputs. Okay. So, in this lecture basically we focused on the crop water requirement, right, and then once you know the crop water requirement, and we also demonstrated that crop water requirement is not same as irrigation water requirement, because irrigation water requirement combines crop water requirement and then other irrigation, the water required for soaking, leaching and saturation. Okay. So, these are all things we need to include in the irrigation water requirement, and then gross irrigation water requirement will be, once you get irrigation water requirement, you can divide with efficiency terms, both application and conveyance efficiencies, you get the gross irrigation water requirement. Okay. So, altogether if you see, you started with as I already explained, to you. So, first evaporation and then transpiration, then combining evapotranspiration by knowing the reference evapotranspiration and crop coefficients. So, once you know the evapotranspiration for a particular day and particular crop, so you can extend that to find out the crop water requirement for the whole for the growing period, for the season. So, once you know the crop water requirement and knowing the other water requirements, irrigation water requirements, so then you can estimate irrigation water requirement, and then finally gross irrigation water requirement for the particular crop and particular season. So, if you have larger area, right, if you have a larger area, so and a larger number of crops, so you can estimate irrigation water requirement, total irrigation water requirement, knowing the irrigation water requirement for individual crops. Okay. Thank you.